This video is over lesson 86, volume of pyramids and cones, and it is for my pre-algebra classes. So ladies and gentlemen, first of all, before we get to pyramids and cones, we need to kind of understand in some ways um, how we come to have them, if you will. So if we start with prisms in cylinders, we can hopefully see that there's a relationship between these figures and then pyramids and cones. And one of the ways we can kind of visualize this is if we start with, let's say, a rectangular prism here. And if you were to imagine a dot in the middle of the top base there, and you were to imagine a sculptor taking a piece of rock that was made in this rectangular prism and shaving away a piece here and a piece there, so that in the end, the sculptor leaves the bottom base intact, but creates a pyramid out of this, then you would see the pyramid lines come down here and here and here, and then we'd have a hidden line back there. And so in some ways you can almost imagine that inside of every prism is a pyramid of the same base. Likewise, with our cylinders, if you were to imagine a block of stone made in a cylinder, and our sculptor is going to take this and leave the base there and going to shave away a piece of rock here and a piece of rock there, and in the end create a cone, you can imagine the lines of this cone coming down and connecting to this bottom circular base. So that inside of every cylinder, there's a cone of the same base. And so there's going to be a relationship here now between the volume of a prism and a cylinder to the volume of a pyramid and a cone. And so for a prism or a cylinder, we've already learned that the volume is capital BH, the area of the base times the height. But remember that our sculptor has shaved away parts of our prism, parts of our cylinder, to create the pyramids and the cones, which means it won't be the full base times height. It turns out that it's going to be 1/3 of the base's area times the height. 1/3. That's the only addition that we have to the formula. It's 1/3. So let's go ahead and try this out. And we're going to start off with scooting down here a few spaces. We're going to start off with a square pyramid. So using a kind of a 3D effect, it's actually going to look like a parallelogram, but you got to kind of imagine that back here, these lines would be hidden in our pyramid. And then I'm going to put an apex up here. So then I'll connect down, and these lines would be visible. They'd be out front, and to complete the 3D effect there, we'd have that line back there that would be hidden. Now it is important that when you're looking for your height, that we understand that the height here has to form a right angle with the base. So let's say that this figure, it's a square pyramid. So each side of the square is 4 centimeters. And then that perpendicular height, I'm going to turn my paper sideways, let's say that that's 6 centimeters tall. 4 centimeters on each side of the base, 6 centimeters tall for the height. So then capital B, we have to calculate. Remember, it's a square. So the formula for the area of a square is s squared. So s, my side, is 4 centimeters squared, which of course 4 centimeters squared is 16 square centimeters. So therefore the volume here is going to be 1/3 times 16 square centimeters, and then times 6 centimeters is the height. Remember that you can do this in absolutely any order that you want since it's all multiplication. So you could do 1/3 of 16, which is not going to come out as a whole number, and then times that result by 6. So they have a mixed number times 6. You could do 16 times 6 and then find 1/3 of that. Or probably the easiest way to go here is to find 1/3 of 6 and then multiply that by 16. So 1/3 of 6 is 2 times 16 is 32. But if I already have 2 centimeters, so centimeters times centimeters, and then times centimeters a third time, this will give me cubic centimeters. So the volume of that pyramid is 32 cubic centimeters. And let's go ahead and check out a cone. So for a cone, I'm going to go ahead and draw the front here that we can see. I'm going to do dashed for the back that we can't. And then I'm going to bring this up to an apex right there. So for this, I'm going to tell you that that got my center and out to there, and we're going to call this 9 miles. This is a huge cone, gigantic, 9 miles in its radius. Now, another way that we can draw height is actually by putting a little tick mark here, kind of in the center of that base. Again, we really have a 3D effect. We should be thinking of it being right level with the base. And then I'm going to put another tick mark up here next to that apex. And then we draw an arrow, or a line, I should say, from there to there. So we're saying how far from here to there. And I'm going to say that this is 13 miles tall. So it's absolutely huge. It's a huge cone. Well, capital B is the area of the base. Well, on a cone, the base is a circle. So the base is pi r squared. So approximately 3.14 for pi. And then r is 9 miles. Little order of operations here. So this is going to be 3.14 times 81 square miles. And then if we multiply those together, this comes out as 254.34 square miles. I'm not going to circle that. That's not my answer because I'm looking for the volume. So now that I know that, here's the thing though, since that's approximately equal to, when we plug it into our formula, that means this is going to turn into an approximately equal to as well. So approximately equal to 1/3 times the base, 254.34 miles, or square miles, excuse me, and then times the height, which is 13 miles. Now remember here that multiplying by 1/3 on your calculator is basically going to be like dividing by 3. So I would, in my calculator, throw in 254.34, multiply that by 13, and then find 1/3 of it divided by 3. And if you do that, it's actually going to come out with a nice number. It's going to come out with 1,102.14. And now here I've already got square miles, times another mile will give me cubic miles. Now, ladies and gentlemen, if that does not come out when you divide by 3 there, but does not come out nicely, then give me another approximately equal to sign here. And since we're rounding off to 2 decimals here, you can go ahead and round off to 2 decimals there as well. So if it doesn't come out nicely, you can go ahead and round to 2 decimals. Well, ladies and gentlemen, this is a fairly easy lesson, so I feel pretty confident that you guys should be good with that, especially with the examples that we've been doing in recent lessons. So that will be the end of our lesson.